This part of the notes, what we're going to go over is how to use dimensional analysis. So, dimensional analysis is something that we do, and it is to convert between units. So, when we're doing this dimensional analysis, what we're going to be converting between is everything that's over here in this side graphic. So, this whole thing over here. What that graphic is showing us is it's showing us how we convert between, let's say, either moles to grams, maybe we want to convert between moles and liters, or maybe we want to convert between moles and particles. Now, representative particles can mean atoms, it can mean molecules, it can mean formula units. Because remember that when we're talking about a mole, we're essentially talking about a counting unit. So just like we said that 1 dozen is equal to 12, a mole is equal to 6.02 times 10 to the 23rd particles. And remember, those particles can be whatever it is that you're counting. So the point of doing dimensional analysis is that maybe we know how many particles there are, but if we're doing a lab, we need to know the mass. We need to be able to measure that in the lab. If we have a mass, that's something that we can do. So as we go through these problems, I'm going to point out all of the different steps that you guys are going to take. Every single step is always the same. You'll have to pay attention to the details, and you'll have to pay attention to what numbers to plug in and what units to plug in, but the overall steps are always going to be the same. So I want to start with this first one. It says how many atoms of nitrogen are in 5.37 moles of nitrogen. So you always want to underline what you're given. You want to circle what it is that you're looking for. So in this problem, we have 5.37 moles of nitrogen. So step one is you're always going to start with whatever it is that you're given. And what you're given, you want to write the number, the unit, and the substance, whether it's an element or a compound. Now, the way we do dimensional analysis is we kind of set this up in fractions in a way. So the second step is we are going to take whatever the unit and the substance is, and we're going to bring that down into the next fraction. So since we had moles of nitrogen given to us, we're going to put moles of nitrogen down in the bottom. So your step two is you want to bring down the unit and the substance. The third step to doing these problems is in the numerator of that second fraction, you want to put the units of the unknown or what you're looking for. So since this asked us how many atoms of nitrogen, we're going to put atoms of nitrogen up here on the top. So your step three is this is where you're going to write your unknown units. Now, for our step four, we're going to plug in something called a conversion factor. And a conversion factor are two numbers that relate units together. So for example, a common conversion factor is that there are 12 inches in 1 foot. That would be a conversion factor. You know that. Another conversion factor might be that there are 3 feet in 1 yard. That's a conversion factor. So a conversion factor for chemistry is how we can relate moles and atoms together. Now, remember this chart that was up here? What you want to look for is you want to look for on this chart the two units that you are converting between. So we are converting between moles and atoms. And remember, an atom is a representative particle. So when we're converting between moles and atoms, the conversion factor we're going to use is in this green box right here. It says that 1 mole is equal to 6.02 times 10 to the 23rd particles. So we're going to use that 1 mole is 6.02 times 10 to the 23rd atoms. Now, we know that the number 1 goes on the bottom because just like there's 12 inches in a foot, there's not 12 feet in an inch. So the number always goes with the unit. So this says, up here, it says 1 mole and then 6.02 times 10 to the 23rd particles. So down here, we have to have 1 go with mole, 6.02 times 10 to the 23rd goes with atoms. Now, to actually solve this, we are always going to multiply everything in the numerators, so everything above the lines. We're going to divide by everything below the line in the denominator. So for this one, what we're technically going to be doing is you want to plug into your calculator 5.37 times 6.02 times 10 to the 23rd. Technically, we also divide by 1. We want to round our answer to 2 decimal places, so your final answer should be 3.23 times 10 to the 24th. And we always need units. We solved for atoms of nitrogen. That's what the question was asking us. Now, remember, as you guys watch these videos, you can always pause, rewind, and go back and double check any part of that problem. These steps that we used, we are going to continue to use these in every single question, even though what we're given and what we're looking for is going to be a little different. So remember, your steps are step 1. Start with whatever you're given, the number, the unit, and the substance. Start with what you're given. Step 2, bring down the unit and the substance. So we have this here. We're going to bring down the same thing. We were given moles of nitrogen. We brought down moles of nitrogen. Step 3, write the unit you're looking for up top. So up here, we were looking for atoms of nitrogen. That's what the question asked us. So we wrote atoms of nitrogen up here. Step 4 is to plug in the conversion factor. You don't want to plug in numbers until after you've written down all of your units. So our conversion factor, which is what we found up here, is that 1 mole is equal to 6.02 times 10 to the 23rd. So we did 1 mole, 6.02 times 10 to the 23rd atoms. Our last step is to solve. Your answer should have 3 parts. It should have a number, a unit, and a substance. So let's go ahead and move on to the next one. It says, if I have 3.68 times 10 to the 24th molecules of water, how many moles of water is that? So the steps are going to be the same. Step 1 is to start with what you're given. In this one, we were given 3.68 times 10 to the 24th molecules of water. All right, we want to go ahead. Step 2 is to bring down the unit and the substance. So we were given molecules of water. That's what we're going to write down here, molecules of water. Step 3 says to put your unknown units on top. This question is asking us for moles. So we want to write moles of water in the top part of this fraction. Step 4 tells us to plug in a conversion factor. So we are looking for numbers that are going to relate moles and molecules. So up here, moles and molecules, we're going to use the same conversion factor we used in the first problem. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Now, remember we said that the number goes with the unit. It's not necessarily always in the numerator or always in the denominator. So for this particular question, what we want to look at is that 1 mole goes on top, And then 6.02 times 10 to the 23rd is in the denominator for this problem. Now, when we solve this, because we have 3.68 times 10 to the 24th in the numerator and 6.02 times 10 to the 23rd in the denominator, we actually want to divide out those numbers, 3.68 times 10 to the 24th, divided by 6.02 times 10 to the 23rd. When you do that, you're going to get 6.11 moles of water. Remember that your answer needs three parts. It needs a number, it needs a unit, and it needs the substance every single time. Now, if you set this up correctly and you're getting the wrong answer in your calculator, you need to make sure that you come see me for that. Because what's probably happening is that you are getting a different, you're plugging something in incorrectly. You might not be using your fraction button or your parentheses the right way. So make sure you come see me for something like that. Now, on the next page, so you're going to be on page 5 of your notes, but I'm going to leave this a little bit different because I still want to show you guys a couple things on this chart while I talk. So this next problem, this one says what is the mass of 5.69 moles of magnesium? Now, this one is not asking for how many atoms or how many molecules. This one is asking for the mass. Remember that the units of mass is grams, which usually we write as just a G. So when we're plugging in units, that's the unit we're going to use for this problem. So step 1, start with what you're given, always. 5.69 moles of magnesium. Now, as you guys are doing these problems, again, even though the units might be different, the numbers might be different, the steps are always the same. So we started with what we were given. Step 2 is to bring down the units. We were given moles of magnesium. We want to bring that down to the bottom. Step 3 is to put your unknown units on top. Now we're looking for the mass. That means our unknown units are grams of magnesium. So step 4 is to plug in the conversion factor. Now, if you notice, this is not moles and particles like we had before. So if you look up at that chart at the top, before we were converting between moles and particles. So we were using Avogadro's number, 6.02 times 10 to the 23rd. But this isn't asking how many atoms or how many molecules or something like that. This one, we're converting between moles and grams. We have to use a different conversion factor. So now, look up at this chart. If you're converting between moles and grams and moles, you have to use the conversion that 1 mole is equal to the molar mass. So 1 mole is equal to the molar mass in grams. The molar mass comes from the periodic table. So if you look on the periodic table and you get the molar mass of magnesium rounded to 2 decimal places, you should get that it is 24.31 grams. Once you have your conversion factors plugged in, because both of these numbers are in the numerator, to solve this, you're going to do 5.69 times 24.31, and you're going to get a final answer rounded to 2 decimal places of 138.32 grams of magnesium. The last sample problem that we are going to do in this video is, this video says this problem says how many moles of sodium chloride are in 351.2 grams of sodium chloride. So we're looking for moles here. Now, the first thing we need to do is we need a formula for sodium chloride. Sodium has a charge of +1, chlorine has a charge of -1. So we're going to go ahead and have the formula as NaCl. Now, I'm sure you guys are sick of me saying these steps. This is going to be the fourth time I've said them. I hope you're sick of me saying them because they're the same over and over and over. So, step 1, start with what you're given. 351.2 grams of sodium chloride. Now, your step 2, remember. Step 2 is always going to be to take the units in the substance, whatever they are from what you're given, bring them down into the next fraction. Step 3, write your unknown units on top. This question, we said that we were looking for moles. So we need to put moles of NaCl in the top of this fraction. Step 4, this is your conversion factor unit. So remember, if I can scroll up really quickly up here, the two units we have are moles and grams. So the conversion factor we need to use is that 1 mole is the molar mass in grams. So we know that 1 mole is the molar mass in grams. Now, we need to get the molar mass of NaCl. So we have sodium has a mass of 22.99 grams. Chlorine has a mass of 35.45 grams. Remember, those numbers come from the periodic table. So now we're going to add those together to get us the molar mass of the whole compound NaCl and get 58.44. Once you have all of that, you're going to do 351.2 divided by 58.44 to solve. Your final answer for this should be 6.01 moles of NaCl. I'm going to go ahead and do some of the next practice problems in another video so that they're split up a little bit. But the main things to remember, and I'll go over it just one more time with you just to make sure that it sticks. The absolute main things to remember is that the steps are always the same. You just need to pay attention to your units and to your details. So step 1, start with what you're given. Step 2, whatever the units are here, bring them down in diagonal. So notice how every problem, these units were brought down. These units brought down, units brought down. Your step 3, whatever your unknown is, whatever the question is asking you for. So this question asked how many atoms. So we put atoms on top. The fourth question asked how many moles. So we put moles on top. The fourth step is your conversion factor. Remember, take a look at this chart. If you're converting from, let's say, moles to atoms or atoms to moles, you're going to use Avogadro's number. If you're converting from moles to grams or grams to moles, you're going to use the molar mass. Last but not least, you need to go ahead and solve. Make sure that if your numbers are in the numerator, that you multiply them. If your numbers are in the denominator, you need to take whatever's in the numerator divided by whatever is in the denominator. Okay, guys, you can try some of the next questions on your own before you load up the next video to see how I did all the answers. Try to make sure that you guys can do these on your own. If you have them set up correctly, but you're not getting the right answer in your calculator, make sure you come check with me in class so that you know how to properly use your calculator.